Level 1. The universe's invisible glue. Dark matter is the first great cosmic insult to human certainty. When astronomers weighed galaxies by watching how fast their stars orbit, the math didn't add up. There wasn't nearly enough visible matter to hold everything together. By all rights, galaxies should fly apart. Something unseen was providing extra gravity, something that doesn't glow, doesn't absorb light, and passes straight through you as if you weren't there. Today, scientists think about 5 times more dark matter exists than normal matter, but they still have no idea what it actually is. If you could step into a dark matter storm, you wouldn't notice anything at first. Your eyes would see only the familiar stars. Your body would feel weightless in the vacuum. Yet every object around you, stars, gas, even your ship, would be subtly tugged by an invisible ocean of mass. You'd watch a galaxy turn in slow motion, its outer stars whipping around far faster than they should, refusing to drift away. It would feel like watching a car take a sharp corner at impossible speed and never skid. We've built underground detectors, chilled them to near absolute zero, and waited for dark matter to tap once on our instruments. Most experiments hear only silence. The universe is clearly hiding something, but it will not say what. And just when scientists thought dark matter was the weirdest cosmic puzzle, space answered with a single deafening shout. Level 2. The fast radio bursts. In 2007, a radio telescope in Australia picked up a flash that lasted less than 5 milliseconds. But in that instant, it released as much energy as the sun emits in a whole day. This was the first fast radio burst. At first, scientists blamed it on interference, maybe a passing satellite, or even a microwave door opening at the observatory. But then other telescopes began hearing the same thing from different parts of the sky. Bursts that appeared out of nowhere, screamed across radio frequencies, and vanished. Some repeat, some fire once, and are never seen again. Imagine you're an astronomer on the night shift. The control room is quiet, the sky is empty and ordinary. Then your monitors spike an impossible vertical line of signal, more intense than anything you've seen. It lasts less than the blink of an eye. You scroll back through the data. No build-up, no fade-out, just a cosmic gunshot from billions of light years away. Today, the leading suspects are magnetars, neutron stars with magnetic fields so strong they can tear atoms apart. Their crusts may crack and snap, releasing bursts of energy that scream across the universe. But FRBs don't all look the same. Some repeat with eerie regularity, like a lighthouse others fire once and fall silent forever. And buried in that chaos, scientists keep looking for patterns, a code, a rhythm, anything. So far, the bursts just keep coming, and the universe refuses to explain why. Even stranger, one baffling star briefly made scientists ask a forbidden question. What if someone built this on purpose? Level 3, Tabby's star and the alien megastructure. That wasn't KIC 8462852 doesn't sound dramatic, but when astronomers pointed the Kepler Space Telescope at it, this ordinary star did something extraordinary. Its brightness dipped hard, not by 1% like a planet passing in front of it, but by 15%, then 22%, at one point almost 40%. Worse, the dips weren't regular. They came in strange clusters and jagged shapes, like someone was randomly blocking the star with sheets of cosmic cardboard. No known planet could do this. No simple dust ring fit the pattern. For a moment, the most sensational idea floated into the conversation. A Dyson swarm, a megastructure built by an advanced civilization to harvest the star's energy. If you were floating near Tabby's star, you might see great veils of dust drifting in curved arcs, clumps of material sliding across the face of the star like slow-motion eclipses. Sometimes, its light would pour over you, so bright your visor would auto-dim. Sometimes, for hours or days, it would fade to an eerie twilight. The alien megastructure idea was thrilling and terrifying. It forced scientists to admit how little they understood. In the end, the best explanation turned out to be enormous. Uneven clouds of dust, possibly from shattered comets or debris disks, blocking different wavelengths of light in different ways. No grand machine, no galaxy-spanning civilization. But Tabby's star left a scar on our cosmic ego. For a brief window, the data pointed to something our theories did not expect, and the universe reminded us that it doesn't owe us easy answers. And then, something truly unexpected didn't just orbit through our solar system, it flew through it. Level 4, ʻOumuamua, the visitor between the stars. In October 2017, astronomers spotted a faint object racing through the inner solar system on a path no comet or asteroid had ever taken before. Its orbit wasn't elliptical, like something tied to the sun. It was hyperbolic and open curve. This thing was just passing through. They named it ʻOumuamua, Hawaiian for a messenger from afar arriving first. As telescopes focused in, the mystery deepened. ʻOumuamua was oddly elongated, maybe 10 times longer than it was wide. It reflected sunlight strangely, and as it left the sun behind, it began to speed up, just a little. That extra push shouldn't have happened without jets of gas or dust, but none were visible. Imagine watching it from the window of a ship parked near Mars. At first, it would look like a dim, tumbling shard against the stars. As it glides past, sunlight glints off its surface in irregular flashes like light off a spinning knife. It doesn't flare with comet tails. It doesn't shed debris. It just silently adjusts course, nudged by some subtle force. Scientists proposed exotic explanations. Perhaps it was a fragment of nitrogen ice, slowly vaporizing, or a pancake-thin sheet of frozen hydrogen. Some even asked whether it could be an artificial sail-thin material pushed by starlight. The data we collected was limited. By the time we realized how strange ʻOumuamua was, it was already racing away into the dark. We may never know exactly what it was, but it proved something profound. Interstellar objects do wander into our cosmic backyard, and the next one might be even stranger. Some messages arrive as objects. Others come as fleeting whispers in our radios. Level 5. The WOW signal and the searchlight in the dark. On August 15, 1977, a radio telescope in Ohio was calmly scanning the sky when one frequency spiked suddenly, violently, unmistakably. The signal lasted for 72 seconds. On the printed data sheet, one number towered above the noise. Astronomer Jerry Amon circled it and wrote a single word in the margin. Wow. The WOW signal came from the direction of the constellation Sagittarius. It was narrowband, concentrated into a tiny slice of frequencies, the way human radio transmissions often are. It didn't drift the way typical natural sources do. If you had been sitting in that control room, you would have watched the glowing green line on the screen begin to rise, then spike so high it almost left the chart. Your heart would have hammered while you checked every cable, every setting, every possible source of interference. Then, nothing. The sky went quiet again. Dozens of follow-up searches scanned the same patch of sky. The signal never returned. Many natural explanations have been offered. A passing comet, a weird reflection, a one-off atmospheric effect. None fit perfectly. The WOW signal sits in a strange limbo, too clean to be dismissed, too fleeting to be confirmed. For 72 seconds, the universe may have shouted at us, or maybe, for 72 seconds, we misheard the static of a much stranger cosmos. Either way, it taught scientists something crucial. Sometimes the most baffling phenomena don't repeat on command, but some of the strangest worlds don't shout at all. They drift in absolute silence. Level 6. Rogue planets, worlds without suns. Not every planet gets to keep its star. In the chaos of planetary formation, gravitational battles can fling worlds out of their home systems entirely. These are rogue planets, dark, frozen wanderers drifting between the stars with no sun to warm them. Astronomers infer their existence by the way they briefly bend and magnify the light of distant stars as they pass in front tiny gravitational signatures of worlds lost in the dark. Imagine landing on one. Step out of your ship and the sky is perfectly black. No sunrise is coming. The only light is from your suit and your instruments. Beneath your boots, the ground crunches solid rock or frozen gas, locked in permanent night. But dig deep and the story might change. Some rogue planets could be warmed from within by radioactive decay or leftover heat from their birth. Under kilometers of ice, an ocean might churn liquid water, shielded from the cold vacuum above. You'd float in pitch-black seas, with only your helmet lamp cutting a narrow cone through the water. Strange chemical life could cling to hydrothermal vents, never knowing that stars exist. For scientists, rogue planets are baffling because they challenge the traditional idea that life needs a star. They hint that there could be more habitable places than we ever imagined, hidden worlds between the stars that almost nothing in the visible universe reveals. And while rogue planets drift silently through the dark, our own galaxy hides something far louder and more violent at its heart. Level 7. The monster at the Milky Way's core. At the center of the Milky Way, 26,000 light-years away, lies a gravitational monster, Sagittarius, a star, a supermassive black hole about 4 million times the mass of the Sun. For decades, its presence was suspected, but unproven. Astronomers tracked stars, whipping around an invisible point, moving so fast that only an enormous, compact mass could explain their orbits. Then, using a planet-sized network of telescopes called the Event Horizon Telescope, scientists finally captured a blurry but unmistakable image, a glowing ring of radio light surrounding a dark circular shadow. If you could float near Sagittarius, a star, you would never survive it, but you would see something unforgettable. Gas and dust spiral inward at nearly the speed of light, heating to millions of degrees. The black hole itself is invisible, but the space around it glows in furious, distorted arcs. Time dilates. As you hover closer to the event horizon, your seconds stretch into hours for observers far away. From your perspective, the universe outside speeds up. Stars age, galaxies drift. The Milky Way slowly turns while you hang on the edge of a dark well. Black holes are predictions of general relativity that the universe went ahead and made real. But some black holes are so huge, so early in cosmic history, that they simply shouldn't exist. Those are the ones that truly baffle scientists. Level 8. The Impossible Giants. Astronomers have found black holes not just millions, but billions of times the mass of the Sun, anchoring the centers of distant galaxies, blazing as quasars visible across the observable universe. Some of these ultramassive black holes were already enormous when the universe was young, less than 1 billion years after the Big Bang. According to our best models, there simply wasn't enough time for them to grow this big, from ordinary stars collapsing and merging. It's like finding a fully grown redwood tree in a forest that sprouted last week. If you approached one in a hardened ship, ignoring for a moment the radiation that would cook you long before you arrived, you'd see an accretion disk stretching light years across rivers of gas and dust plunge inward, heating and glowing brighter than entire galaxies. Jets of particles shoot out from the poles at nearly light speed, carving glowing beams through intergalactic space. If your ship crossed one of those jets, you'd be shredded at the atomic level matter, stripped down to pure energy. To explain these monsters, scientists have proposed direct collapse black holes, enormous clouds of primordial gas collapsing straight into black holes without ever becoming stars. Others invoke runaway mergers or exotic dark matter relics. None of the explanations are fully satisfying. These giants sit in the dark, bigger than our theories expected, radiating power we barely understand. And as if that weren't enough, the very fabric of space between them is doing something even weirder. Level 9. Dark energy. When space itself won't sit still. In the late 1990s, astronomers studying distant supernovae expected to find that the universe's expansion was slowing down. Gravity should be gradually pulling everything back together. Instead, they found the opposite. The expansion of the universe is accelerating. Galaxies aren't just drifting apart, they're being pushed apart faster and faster over time. To account for this, scientists invoked a new mystery: dark energy, a kind of energy inherent to space itself. It doesn't clump, it doesn't glow, it simply causes space to expand. Today, dark energy is thought to make up about 68% of the total energy in the universe. If you could somehow see it, the void between galaxies would look like a restless ocean. You'd watch distant clusters drift away, faster and faster, not because they're moving through space, but because more space is constantly appearing between them. Far in the future, if dark energy continues its work, galaxies beyond our local group will slip over our cosmic horizon. Their light will never reach us. The night sky will grow emptier, the universe quieter, until we are effectively alone. Dark matter tells us we don't know what most of the mass in the universe is. Dark energy tells us we don't know what most of the universe is. And somewhere in between, on the grandest scales, gravity is doing something that doesn't quite line up with our maps. Level 10. The Great Attractor and the Cosmic Flow. Every galaxy moves not just spinning, not just orbiting within its cluster, but drifting through space on long, slow trajectories. Our own Milky Way, along with thousands of nearby galaxies, is rushing toward a region of the sky known as the Great Attractor at hundreds of kilometers per second. But when astronomers point their instruments in that direction, they find mostly dust and confusion. The Great Attractor sits behind the thick, crowded plain of the Milky Way, where gas and stars block our view. We see hints of massive clusters and superclusters, huge concentrations of galaxies, but they don't seem quite large enough to account for all the motion we observe. If you could ride along on the Milky Way itself, you wouldn't feel this motion. Space has no air, no wind on your face. But over millions of years, the constellations would slowly distort as our entire galactic neighborhood falls towards some deeper gravitational basin. Zoom out even further, and you see another puzzle. Structures on scales bigger than some theories predict should exist. Gigantic walls and filaments of galaxies, stretching hundreds of millions of light years across, like cosmic spiderwebs frozen in time. These flows and patterns force scientists to question how matter clumped together after the Big Bang, and whether our models of gravity and dark matter are complete. And while the large-scale universe behaves strangely, individual stars sometimes defy death in ways that break the rules closer to home. Level 11, the star that exploded. Again, when a massive star dies, it collapses and explodes as a supernova, one titanic blast, and then it's over. At least that's what should happen. In 2014, astronomers observed a supernova called IPTF-14HLS that refused to follow the script. It brightened, dimmed, then brightened again, over and over for years. Even stranger, when researchers dug through old plates, they found evidence that the same star might have exploded once already in the 1950s. It was nicknamed the zombie star. If you were close enough to see it, the first explosion would stun you. A star turning into a sun-wide fireball, radiating more light than 1 billion suns. Shockwaves rip through surrounding gas, heating it to incandescent temperatures. You'd wait for the glow to fade. Instead, months later, the star surges again like a dying heart beating once more. The sky flashes, the debris shell brightens, and you realize this object is dumping energy on a scale that standard supernova models can't explain. One proposed explanation is a pulsational pair instability supernova, where the star's core briefly converts energy into matter-antimatter pairs, partially collapses, then rebounds multiple times before final collapse. But even that doesn't comfortably fit all the observations. IPTF-14HLS is a reminder that even the simple story of star death still hides strange exceptions. And on the largest scales of all, the entire universe may itself be an exception, one bubble in a far stranger reality. Level 12, the multiverse and the edges of what we can know. Our final phenomenon isn't a single object or event. It's a possibility that emerges from the math of our best theories. When cosmologists run the equations of inflation, the rapid expansion thought to have occurred just after the Big Bang, they sometimes find that inflation doesn't end everywhere at once. Instead, pockets of space stop inflating and become normal universes, while inflation continues elsewhere, spawning more and more bubble universes without end. Welcome to the idea of the multiverse. In some versions, each bubble universe has slightly different physical constants, different strengths of gravity, different numbers of dimensions, different chemistry. Most would be sterile. A few might allow stars and galaxies. An even smaller fraction might allow life. If you could somehow stand at the edge of our cosmic bubble, ignoring the fact that physics forbids it, you might see other universes butting off into an inflating background, like glowing lanterns drifting in a dark river. You'd never reach them. Their space is not our space. Their timelines do not intersect with ours. For scientists, the multiverse is both tantalizing and frustrating. It offers explanations for why our universe seems finely tuned for life, because only universes that happen to allow observers will ever ask the question. But it also pushes right up against the limits of science. A multiverse that can't be tested sits somewhere between physics and philosophy, and yet it may be the ultimate baffling space phenomenon, not because it breaks our equations, but because it might explain too much and confirm too little. Living in a universe of questions, from invisible matter to impossible black holes, from rogue planets to fleeting radio whispers, every phenomenon we've explored has something in common. It marks a boundary. Each one is a place where human understanding thins out and the universe refuses to fully cooperate with our theories. If you step back and look at the sky from Earth, none of that is obvious. You see a calm dome of stars, maybe a hazy Milky Way on a dark night. It feels still, ancient, resolved. But behind that calm surface, space is wild and unfinished, full of puzzles that keep the brightest minds awake at night. You live on a small, fragile world, orbiting an ordinary star, in the quiet suburbs of a galaxy, falling toward an unseen attractor, in a universe dominated by things we barely understand. And yet, That ignorance is a gift, because it means there is more to discover, more signals to catch, more visitors to chase, more theories to break and rebuild. The cosmos is not a solved problem. It's an open question. So keep looking up, keep wondering why. And if you want to keep exploring the mysteries that still baffle scientists, from black holes to alien worlds, subscribe for more explorations. Out there, the next unsolved phenomenon is already on its way toward us.